Valence shell electron pair repulsion theory. Nihilm and Gillespie developed Vsepr theory to predict shape of molecule. The electron pairs in the valence shell around the central atom of a molecule repel each other. They tend to orient in space so as to minimize their repulsions and maximize the distance. There are two types of valence shell electron pairs: 1, bond pairs, and 2, lone pairs. The bond pairs are usually represented by a solid line, whereas the lone pairs are represented by a lobe with 2 electrons. The order of repulsion between different types of electron pairs is as follows: lone pair greater than lone pair, bond pair greater than bond pair, bond pair. When the valence shell of central atom contains only bond pairs, the molecule assumes symmetrical geometry due to even repulsions between them. Example: linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, etc. When the valence shell of central atom contains bond pairs and lone pairs both, then geometry of molecule is distorted due to uneven repulsion forces. Examples: V-shape, T-shape, seesaw, pyramidal, etc. In this theory, the electron pairs in multiple bonds are treated collectively as a single superpair. Triple bond causes more repulsion than a double bond. Primary and secondary effects on bond angle. The bond angle decreases due to the presence of lone pairs, which cause more repulsion on the bond pairs, and as a result the bond pairs tend to come closer. The bond angle increases due to more electronegativity of central atom than surrounding atoms. Shape of molecules: linear, bond angle 180 degree. Example: beryllium chloride, trogal planar, bond angle is 120 degree. Example: BF3, V-shape with 1 lone pair, and bond angle less than 120 degree. Example: singlet carbon, tetrahedral, bond angle is 109 degree. Trigonal pyramidal with 1 lone pair, bond angle less than 109 degree. V-shape with 2 lone pair, bond angle less than 109 degree. Beryllium chloride gas, BF3, CH2, CH4, NH3, H2O. Trigonal bipyramidal, bond angle 90 and 120. Axial bond longer than equatorial. Example: phosphorus pentachloride, seesaw shape with 1 lone pair, bond angle less than 90 and 120 degree. Example: SF4, T-shape with 2 lone pairs, bond angle less than 90 degree. Example: bromine trifluoride, linear shape with 3 lone pairs, bond angle is 180. Example: xenon difluoride, phosphorus pentachloride, SF4, bromine trifluoride, xenon difluoride. Octahedral shape, bond angles 90 and 180. Example: SF6, square pyramidal with 1 lone pair, bond angles are less than 90 degree. Example: bromine pentafluoride, square planar shape with 2 lone pairs, bond angle 90 and 180. Example: xenon tetrafluoride, SF6, bromine pentafluoride, xenon tetrafluoride. Tetragonal bipyramidal, bond angles are 72, 90 and 180 degree. Example: IF7. Now it's distorted octahedral with 1 lone pair. Bond angles are less than 72 and 90. Example: xenon hexafluoride, pentagonal planar with 2 lone pairs. Bond angles exact 72 degree. IF7, xenon hexafluoride.